Lesson 17.3, Task 1. Solve quadratic equations by factoring ax squared plus bx plus c. Alright, so in the last lesson you factored expressions of the form x squared plus bx by factoring out the greatest common factor. You can use the same process to factor an expression of the form ax squared plus bx when the leading coefficient a is not equal to 1. For example, consider the expression 3x squared plus 9x. Alright, so you can see here, if we have an expression, 3x squared, again, thinking about properties of exponents, 3x squared can be written as 3 times x times x. X squared is just x times x because x to the first power times x to the first power. When you have the same base, you add exponents and that would become a 2. So this is just another way to look at that. And then 9, we know that 9 is 3 times 3 and then times x. You don't want to forget your variable. So in this second row here, they've just rewritten what they were given, so that makes it easier to see what the common factors are. So you can see that this, everything's divided by a plus or a minus. So this is one term and this is your second term. So this is considered a binomial, 2 terms. And we've got 3x and we've got 3x. So those are our greatest common factors. So we're going to pull out the 3x. And what does that leave us? That leaves us with x plus 3. And you can always use distributive property to see that what you did is the same as what you started with, because we're rewriting it in factored form, but it still should be equivalent to what you started with. So 3x times x is 3x squared. 3x times 3 is 9x. And that way I know that I factored it correctly. Okay? Alright, so it says here the greatest common factor of 3x is shown in blue. An expression for the area of a flag is given, where x represents the width of the flag. Alright, so the area is 5x squared minus 10x. It says what is the greatest common factor of the terms 5x squared and 10x. Alright, so if you want to do this one like the one above, you can say 5x squared minus 10x. We can rewrite 5x squared as 5 times x times x. Remember, x squared is x times x. And then 10 is 2 times 5 times x. And why are we rewriting this as factors? Because this one has a 5. And we know that 10 is 2 times 5, so we're just trying to find everything that these two terms have in common. So now that we can see they have 5x in common, and we're left with x minus 2. And again, check it, 5x times x is 5x squared. 5x times negative 2 is negative 10x. So we can see that that does work the same as it did before. So that should always work. So A part says what is the greatest common factor of the terms. So we don't just want a common factor, we want the greatest common factor. So that would be 5x. If you factored out just 5 times x squared minus 2x would still produce this. But if you don't pull the x out with the 5, you didn't pull out the greatest common factor. So make sure you always do everything that can be factored out, you want to pull out so that you find your greatest common factor. Alright, so it says completely factored means there are no further factoring can be done to an expression. Choose the correct expression to complete the statement. The completely factored form of the area is, well, 5x times x minus 2. So 5x times x minus 2 is the completely factored form. 5x is the greatest common factor of this binomial, but this is the completely factored form. Alright, so it says which of the following is an expression for the length of the flag in terms of the width? Alright, if you go back up here, you can see that the area is 5x squared minus 10x. So that's what we've been working with right here. Okay, and we know that the area is length times width. So we can see that length times width would be 5x would be your length, x minus 2 would be your width. And if we're saying that the length of the flag in terms of the width, okay, if we're saying this is our width, we know that the length is 5 times that. So 5 times x minus 2 would be that expression, okay? All right, so let's see what this last question says. The area of an object and its dimensions must be positive. All right, so that makes sense because length has to be positive, width has to be positive. We can't have negative distance. So it says complete the statement concerning what this implies about x. So it says the dimensions are positive precisely when, all right, so if we look, at our factors, we had, you can actually still see them right here. We've got 5x times x minus 2. So for this to be positive, we can just set these equal to 0 and solve. So this has to be greater than or equal to 0. We'll set it equal to 0. So if we divide, we're going to get rid of 5x equals 0. So what we're actually doing is just looking at the zero product property again that we've already learned. And the zero product property says, all right, so x equals 5, that's fine. And x equals 2. So 2 is smaller than 5, so we're going to say the dimensions are positive when x is greater than 2. So if you have anything less than 2, it's not going to be greater than that. So these conditions work because, again, we want the length and the width to be positive. All right, if you have any questions, let me know. Lesson 17.3, Task 2. Factor ax squared plus bx plus c when c is greater than 0. Given an expression of the form ax squared plus bx plus c with integer coefficients, you may be able to factor the expression as mx plus p and nx plus q for integers mn, p, and q. By expanding, you can see how the coefficients in the factored and unfactored forms are related. Notice that m and m are a factor pair for A and P, and Q. A and P and Q are a factor pair of C. Okay, so what they're doing is basically replacing the standard form, which hopefully you will become really familiar with by the end of this year. Ax squared plus bx plus c is a quadratic equation in standard form, and what they're saying with all of these new letters here is basically what they're saying is if we write this from standard form to factored form, they're just saying that A can be replaced by m and n, B can be replaced by m times q plus n times p, and then C can be replaced by P and Q. So what they're doing is just substituting variables in, because when you factor, you're going to have more expressions. So they're just using variables to kind of represent that. So let's look at an example, because I think it's easier to look at examples sometimes than just the general formula. So it says if we try to factor 6x squared plus 13x plus 5, it says complete the equations with the values for A, B, and C. All right, A is always my quadratic term, so that means it's in front of my x squared. So A is 6. B is my linear term, so it's in front of my x, so it's 13. And C is my constant term, so it's going to be 5. All right, so it says, suppose you want to factor 6x squared plus 13x plus 5 into the form they showed above, where m and n are positive, and then wants to know why p and q must also be positive. All right, so if 6 is positive and 5 is positive, then it just stands to reason that 13 is going to be positive as well. Because remember, when we factor, think of distributive property, you're going to go first term times first term times last term, and then the second term times first term, and the second term times last term. Some people call this FOIL. I call it distributive property. Either will work as long as you do all of the steps and then combine like terms. So it says explain why LN equals 6, PQ equals 5, and the combination equals 13. So A is the same as LN if you remember above. When we looked at it in factored form, you can see LN was A, and then this expression is B, and this expression is C. So we've already kind of looked at that and kind of explained that right there. All right, so the next question says, refer to the spreadsheet to answer the following questions. All right, so again, we're going to look at one of these to factor. Let me find my pen here. All right, remember LN, 6, so this is the same as A. And then PQ, so this is going to be my C value. And then if I add these together, I need to get the middle term, which is equivalent to B. So they're using L and N, P and Q, and this combination to get B. But really, these are my terms, my factors of A. A here is 6. And then C is 5. That's my factors here. And then the combination of those to get 13 at the end. So the combination of 13 is what we're looking for. So we're going to use these numbers in this row here. See if I can highlight these here. And that's going to tell me what the factored form is. So you may have to generate a table of values in order to find these. All right, so it says based on the spreadsheet, what is the factored form of this expression? So we're going to have L and N. So we're going to have 3 and 2. So it's got to be one of these second two. So it's going to be 3 and 2, and then 5 and 1. So 3 and 2, and then 5 and 1. So the order here would matter because that's going to give us 13 in the middle. So check it. 3x times 2x is 6x squared. 3x times 1 is 3x, plus 10x. 3 plus 10 is 13x, and 5 times 1 is 5. So that is correct when you check it. All right, now it says select the number to complete the statement about the spreadsheet. The rows where that equals 13, that's your B, gives the coefficient and constant terms for the factored expression. So that is true. All right, so it says, Lee thinks the spreadsheet in part C doesn't account for all possibilities. She adds 4 more rows by swapping the values in columns A and B. So before it had 6 and 1 and 3 and 2, and you can see that she's just swapped these out, but then you get a combination is going to be the same at the end, and we're still going to have the same outcome even though she swapped the answers. So it says, why does adding these rows not necessary? Select the phrase to complete the statement. If Lee swaps the order of M and N, then the order of P and Q will also swap. However, the original spreadsheet already had P and Q in both orders, so the additional rows produce possible factors that are already listed. All right, I'm going to stop here and I'm going to finish the last 2 factoring on the next video. So if you have any questions, let me know.